from the greatest integer function, and I will generally write it in this form here, but it means we want to know the greatest integer that is less than or equal to x. Now, I messed up yesterday. I wrote on the board the greatest integer that is greater than or equal to x, which there would be no answer there. It'd be infinitely large. And it took me, they said, that doesn't make sense. I was like, yeah, it does. And then I thought, oh, stupid me. Anyway, all right, so we're back here. So it's the greatest integer that is less than or equal to x. So if I have this written right here for 2.7, what would be the greatest integer that's less than or equal to 2.7? 2. We did? Were you in my humanities class? All right. For pi? 3. For 78? 78. Negative 2.3?
Negative 3.
Negative 3, yeah. It's negative 3. Got to be careful with the negatives. So, graphically, what is happening here? And I messed the graph up yesterday. Yesterday was not my shining moment, but they did come in and they did find the kryptonite that was in my classroom and they got it out, so I won't make those mistakes today. So I've got negative 2, negative 1, negative 1, negative 2, 1, 2, 1, and 2. All right, so think about this. Okay, here's negative 1/2. What's the greatest integer that's less than or equal to negative 1/2? Negative 1, right? So we're here. Greatest integer that's less than or equal to negative 1 is also negative 1, right? So it comes up to here. Now, when we get right here at 0 and we plug in 0, what's the answer? 0. So we jump up here, 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 here. And I'll go ahead and put it here. Okay. So that is what we're looking at as far as this graph of the greatest integer function. Now this is one rare case in which you can plug in a number and get an answer and it not necessarily be the limit. So let's talk about it. Let's just talk about it first by analyzing the graph. What is the limit as x approaches 1 from the right of the greatest integer function?
1.
It's 1, right? As I approach 1 from the right, I'm on this little horizontal segment right here, and I'm approaching that y value of 1. All right. We practiced this before class. All right. What is the limit as x approaches 1 from the left? Well, I'm talking about numbers like 0.9, 0.99, 0.999. What are all those values? 0. So as I approach 1 coming in from the left, I'm right here, right? So what my limit is 0 or 1? 0, yeah. I'm getting close to 0. Doesn't matter what I am at 1. What am I at? 0.9999999. I'm 0. So the limit as x approaches 1 from the left is 0. So what is the limit as x approaches 1 of the greatest integer function?
Does not exist.
Does not. Is there ever a case where the limit would exist on a greatest integer graph? Let me ask that question again. is there ever a point on the greatest integer graph where the limit does exist?
No.
Between the integers.
Yes.
So, if I say, that was beautiful, the limit as x approaches negative 1/2. All right? From the right, all right, negative 1/2 is here, right? So my y value is here. What y value am I approaching as I approach negative 1 from the right? Negative 1/2, I'm sorry, I said that wrong. Negative 1. What is my limit as I approach negative 1/2 from the left? Also negative 1. So what is the limit as x approaches negative 1/2?
-1.
Negative 1. Last year, I gave this next problem. And the class was very appreciative of this problem. In fact, the night after I gave this problem, they decided that they would reward me by giving me toilet paper and eggs in my yard. That was beautiful. So, here we go. The limit as x approaches 0.99. Well, this is my question. So before I start this question, I know if the left-hand limit is equal to the right-hand limit, then the limit exists, right? Okay. If the left-hand limit does not equal to the right-hand limit, then the limit does not exist. So let's talk about the limit as x approaches 0.99 from the left. And then let's talk about the limit as x approaches 0.99 from the right. And I'm putting f of x. F of x is the greatest integer function. All right. So, here's 0.99. It's 0, right? So if I'm approaching from the left, I'm at 0. What about approaching it from the right?
0.99.
You sure?
No.
What do you think it is?
0.99. No.
It is 0.
It is 0.
I'm sure.
The whole thing is if I chunk a magnifying glass up here, here's 0.99. There's still a lot of room between 0.99 and 1 where it makes the jump. So for that very reason, we get 0. So the limit as x approaches 0.99 of the greatest integer of x would be
0.
0. Now, some of you said 0.99. Remember, our answer needs to be an integer in that case. Yes?
What would happen if it was like empty close, like 0.9 and not repeating?
You can always get closer.
Yeah.
You just may need a microscope instead of a magnifying glass, but you can always get closer until it hits that integer. And right when it hits that integer, that's where it makes the jump.
So you can get like infinity closer. What if it's infinity?
What is the limit as x approaches infinity? Doesn't exist, does it, right? Because this graph is gradually increasing forever and ever and ever. Don't y'all just love this? It's making you think. And this is good stuff. Huh?
I like this one. I don't like the other one.
Squeeze through 'em?
I don't like
I
that
don't
one.
like
But
that.
this one is easy. I like this one.
All right.
I was
That one was foul.
confused.